Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. Today our lecture is about the bending stiffness. Bending stiffness, also known as the transverse stiffness. Transverse stiffness. I will try to explain this topic with the help of this figure. This is in a simply supported beam and this is the axis of this beam. And let's suppose this is any uniformly distributed load acting on this beam W, and this load is acting perpendicular to the axis of this beam. So we call that this load is a transverse load for this beam because it is acting transversely to the axis of the beam. So due to this transverse load acting on this beam, it will show some resistance to the upcoming load. So there will be some internal resistance to this upcoming load inside the beam in order to take this load. So this internal resistance is basically known as the bending stiffness of the beam. And this stiffness is known as the bending stiffness because this beam will show some bending. That's why it's known as bending stiffness. If I show it by line diagram, let's suppose this is any beam, the simply supported beam, and this is the distributed load on this beam. So due to this load, the beam will try to bend in this way. So some bending will be created inside this beam, but it will also show some resistance to this upcoming load. So that's why its name is bending stiffness, because the stiffness is due to the bending of this beam. The load acts on this beam and it shows bending, and also it shows resistance. That's why it's called as the bending stiffness. So basically, bending or the transverse stiffness is the resistance of the beam to the upcoming load. So if I write the transverse or the bending stiffness formula, so the bending stiffness, its formula is E multiplying with the I dividing by the length. So we can find out the bending stiffness or the transverse stiffness for any kind of beam if we know the elasticity of the material used in this beam, if I know the moment of inertia of this beam, which we can find by if this is any rectangular or square column. So if this is, let's suppose, B and this is H, so we can easily find out the moment of inertia for this is BH cubed by 12. So it depends on the section of the beam. If you know the moment of inertia of the beam and L is the length of this beam, if we also know the length of this beam, so we can find out the bending stiffness for this beam. And higher the bending stiffness of the beam, it means higher it can take the load. And bending stiffness depends on these three properties. Higher the elasticity of the material, the higher will be the bending stiffness of this beam. Higher is the moment of inertia, higher is the cross section used, so higher will be the bending stiffness, and shorter the length of the beam, higher will be the bending stiffness of this beam. Hope you guys understand that what is the bending stiffness and on which factor it depends. For daily civil engineering videos, please subscribe our channel. Thank you for watching our video.